You're listening to A Climate Change. This is Matt Matern, your host. I've got a great guest coming on the program today. I'm really excited about having him on the show, doing some amazing work out in academia as well as in, quote, the real world. So it's always fun to have somebody who's a kind of an intellectual giant on the show and we get to learn a lot. I think that's one of the most fascinating things that I've been privileged to be a part of, is talking some real thought leaders about what's happening in the environment and some of the amazing things that are being done to help make our world a better place. So I like to live in the solution, and our guest, Gaurav Sant, is a person who's living in the solution. He's taking carbon and making it into concrete. That's a pretty revolutionary concept. And so we're going to be talking to Gaurav about that. Everybody, please check out our website, climatechange.com, if you want to see some old or listen to some old episodes that we have on there, as well as if you miss any part of this on the radio broadcast, you can always go back and check that out. Without further ado, Gaurav, welcome to the program.
Thanks for having me, Matt.
So tell us a little bit about your journey to get to where you are, as far as the work that you're doing and taking carbon and turning it into concrete. I also had read some interesting stuff that you're taking carbon out of the ocean and turning it into hydrogen, and that to me is revolutionary as well. So a lot of ground to cover.
Yeah, thanks for the opportunity. So I'm a third generation civil engineer. I grew up on the west coast of India. I moved to the US to go to college. My grandfather built half a city in India. My father built half a state in India. And I've been privileged to watch what development and particularly civil engineers can do to affect people's quality of lives. As I made my way through my own career, I sort of often ask that question to myself. And I was fortunate enough to have the opportunity to create UCLA's Institute for Carbon Management. And we're a translational institute. And what that means is we don't do discovery research, but we take technologies from the bench scale to commercial or pre-commercial prototypes. We're really focused on carbon management, and particularly the avoidance, the removal, and the utilization of emissions. And really, how do you do this in an affordable way, in an accessible way, and how do you do it in a manner that's globally scalable? And one of the things that's both fascinating and daunting about the carbon management challenge is that we produce more carbon dioxide than anything else that humanity has ever produced. The problem is all of this carbon dioxide is a waste, and we allow it to accumulate in the atmosphere. And that leads to climate change and where we are today. When we set up this institute, we were really focused on thinking about pathways by which we could affect and effect carbon management, with really a view on thinking about non-geological sequestration pathways, right? So thinking about approaches where you do not put carbon dioxide into reservoirs within the earth as a matter and manner of storing it. We were really focused on everyday industries. We were focused on things like cement and concrete. I trained to be a cement chemist for whatever it's worth. We were focused on things like energy at large, because the energy sector is such a big contributor to carbon emissions. And then we were focused on, what sort of enabling technologies are really necessary to make carbon management feasible. As a function of the fact that I trained to be a civil engineer, cement and concrete is sort of dear to me. We can't imagine a world without cement and concrete, but this is a big industry, and it's a industry that has a massive challenge. So the production of cement, which is the glue that holds concrete together, is responsible for nearly 10% of global carbon emissions. And so this is a sector that we were really focused on. We've often heard about the idea that there's a need to remove carbon dioxide from the atmosphere. There's a need to prevent carbon dioxide from getting to the atmosphere. But current pathways are really expensive, and we were interested in things and ideas around, can you really create valuable products that could reduce the cost of carbon management? And this is where we were really interested in this idea of turning carbon dioxide into concrete. This is also the thesis around which we work on Project Sea Change, which has now turned into a company called Equatic, which produces hydrogen while simultaneously affecting carbon removal from the oceans. in each case, you can see that there's a thesis around it, that you produce a product that allows you to offset the cost of carbon management. And that's sort of how we've headed off on this journey.
So tell us the Sea Change project. Tell us more about that. I'm really fascinated about that. And what was the genesis of that project, and where are you at now, and where are you hoping to go?
Yeah, this is something that I'm really excited about. So we've been working on Project Sea Change for nearly about 5 years now. And the entire thesis was conditioned around two or three things. Number one, the oceans are in effect the largest remover of CO2, so to speak, in the world by far. So 30% of all of the CO2 that we put into the atmosphere is in fact absorbed by the oceans. But the oceans are now capacity capped and they can't remove any additional CO2. This is number one. Number two, the oceans cover 70% of the Earth's surface, which is quite attractive because if you had a mechanism and a way of being able to stabilize and store carbon dioxide durably in the oceans, this could be really exciting as well. And finally, the oceans contain 150 times more CO2 than air per unit volume. And so if you've got to try and remove CO2 from the oceans, it's far easier than doing it from the air, because there's a continuous exchange equilibrium between the atmosphere and the ocean. So any CO2 that we put into the atmosphere is eventually absorbed by the oceans. And what that means is, it's kind of like a dish sponge. If you have a sponge that's really wet, you squeeze it. Now it's got some capacity to absorb water again. That's exactly what we're trying to do with the oceans, except that we're doing it with carbon dioxide. The concept of the process is actually really straightforward. You're taking some seawater and you're running an electrical current through it. What electricity allows us to do is it allows us to trigger a series of really specific chemical reactions that allow us to store carbon dioxide in the form of mineral carbonates, things like materials like seashells are made of, calcium carbonate, and to affect the alkalinity such that the oceans can store more CO2 within them. This is the whole crux of the process. And the nice thing is, since it's based on a chemical process that's known as electrolysis, we're essentially splitting water. And if you think about what splitting water does, is it gives you hydrogen and oxygen. And this is how we're producing hydrogen, which is a clean fuel, and oxygen, which is a valuable chemical commodity for a variety of products and processes.
In terms of the amount of electricity that it takes to split the water, I've talked to some people about creating hydrogen, and there's some people who say, well, it takes too much electricity to split the water molecule, and it's less efficient, and yada yada. So, what's the response to that?
Two comments here, right? So, in general, of course, it does take electricity and it does take energy to split water. But if you can do this in a way where you're doing it not simply to produce hydrogen, but also affecting carbon removal at the same time, you're essentially getting a 2-for-1. When you consider this approach of being able to get a 2-for-1, in fact, both the economics, but also the energy balances of the process actually look really good. And this is one of the fundamental reasons why we chose to go in this direction of affecting both carbon removal simultaneous with hydrogen production. An important aspect which should be emphasized as related to this manner of carbon removal is that the manner in which you end up storing carbon dioxide in the oceans gives you a stability well in excess of about 10,000 years. And so what that means is you're really doing some very durable forms of carbon management, which I think is important when you think about the fact that, we want to be able to store carbon dioxide durably enough, long enough, and in a manner and a matter that's relevant to geological scales.
Right. One of the things that I read was that you are shooting for, I don't know if you're there yet, of producing hydrogen at $1 per kilo. And that's essentially in line with what the Biden administration's Earthshot goal was to produce hydrogen at $1 per kilo. Where are you at in that process? And if you did, it would be revolutionary, because then we could afford to power so many things off of hydrogen more cheaply than fossil fuels, right?
Great comments, Matt. Maybe a couple of things to point out, right? So we've been working on this adventure for about nearly a half decade now. What we've done is that we've systematically come up in our understanding and on the scale curve. So going from things that operate in a laboratory bench to now having equipment and devices that are sitting on a 100-foot barge in the port of Los Angeles and at an industrial facility in Singapore. The idea of being able to do this is to demonstrate the process at a meaningful scale, try and understand what it takes to build commercial scale plants, and to try and understand the economics. And having spent a fair amount of time looking at this, we indeed think we're going to lie well at the bottom of the cost curve around hydrogen production. And you're exactly right. Having access to cheap green hydrogen is fundamentally important to be able to displace fossil fuels as the energy medium of choice. And if you think about what $1 a kilogram translates into, it's exactly that. You said it exactly right. You end up with an energy source that's considerably cheaper than fossil fuels as we know them today.
Well, it's pretty revolutionary stuff you're listening to here on A Climate Change. We'll be right back in just 1 minute with Professor Sant. You're listening to A Climate Change, and this is Matt Matern, your host, and I've got Professor Sant on the program. We're just talking about hydrogen and how we can get it down to $1 per kilo, which is going to clean up and green up our planet. Professor Sant, take it from there.
I think an important thing to also point out when we think about carbon management is to really think about processes that can achieve incredible scale. An important part that we think is really foundational to Project Sea Change is that because the process relies only on electricity, seawater, and rocks as a pathway to operate, it's something you can do all around the world and using materials that we can find all around us. I think, when we think about the scale, the size, and the scope of the carbon management challenge, what is really important is two things. A, can you do this anywhere in the world? B, can you do this cheaply enough anywhere in the world? As we set about thinking about this process, I think, these were really sort of fundamental tenets that we were focused on, because this is not a problem of nations. It's a problem of society. And what that means is we need to enable nations all around the world to be able to exercise processes of this sort. And if you can do this in a way that, you both affect carbon removal and you provide a source of green energy, you can do it at incredible scale and have broad societal buy-in to using processes of this sort for carbon management.
So, what are the next steps for Project Sea Change? You've started the model for it, and how is it working? What do you see is the types of breakthroughs that you need to have, or incremental changes to get it to the point where it's getting closer to $1 a kilo, and we can move forward on a worldwide basis.
So this is really sort of now a matter of speed and scale. The way that UCLA's Institute for Carbon Management is set up is we really think of ourselves as a de-risking platform, with the objective being that you de-risk technology and bring it to a point that it now becomes suitable for scaling in the commercial world. I think we're at the point that we've now done that. We've demonstrated that this process works. It offers, I would say, highly attractive economics. There is a pathway here. What is now necessary is to really take this out into a company and to go out and do this at really large scale. And I think this is really what the next part of the adventure looks like. How quickly can you build really large plants at scale? How do you do this all around the world? And what does that pathway look like? And I think this is what sets the transition for really thinking about a commercial deployment scenario. I think in addition to that, the reason that you want to be focused on coming up in scale and building out quickly is there's a lot that you learn while doing. So learning while doing is something that's really important, but also as you increasingly produce in larger and larger volumes, costs come down. And so you really want to try and understand what these reductions in costs look like, because both of these aspects related to really learning while doing and bringing costs down are now sort of fundamental to thinking about what does large-scale diffusion of a technology of the sort in the world look like.
So in terms of your company that you've created that is working on this, are you looking at licensing this technology to other companies, governments, or rolling it out just through the company that you've created to move forward?
I think the short answer is for right now, it's early days, but it seems like a good initial starting point is to really be the technology provider and the project developer simultaneously. These are new technologies. And so what you really want to do is you want to be able to build confidence. You can demonstrate that it can be done. And so maintaining control of the process initially makes a lot of sense. Once you've gone out and you've sort of shown the world that this can be done, the economics is strong, and there's a track record here, then it's much easier to be able to go out and diffuse it and offer it to other people as, here's technology, you can go deploy it on your own as sort of a technology license. But initially, it makes a lot of sense that you take responsibility of showing that pathway, both to profitability and to scale on your own. Of course, this can change any time, as you know. We might end up showing success far sooner than we thought. And that might create opportunities that we haven't thought about yet. And so I think you want to have a combination between focus, but also flexibility, so that you can pivot with the opportunity and the times that you're in.
Right. So are you getting any help from the government in terms of buy-in from, say, the federal government, state government, to fund some of your work there?
So in fact, the federal government, through the Department of Energy's Advanced Research Projects Agency for Energy, has actually been a big support of the work. They've been really focused on trying to help us develop new types of electrode materials, as an example, for these plants. And so indeed, they're an important player that we work alongside.
I had Jigar Shah on the program about 3-4 months ago, and he's at the Department of Energy in charge of kind of directing, I think it was about $40-50 billion worth of loans. Did you hit up my friend Jigar for a billion or two?
We haven't hit up Jigar for anything just yet, but we absolutely do imagine that the loan program office is going to be an important office for us to be speaking to in due course.
Okay. Well, it sounds like what you're doing is right in line with what they're trying to do, and so I think you should give them a shout out and say, "Hey, this is time for us to have a sea change here." So, where are you at in terms of raising funding and taking the next steps with that technology that you have developed?
Well, it's one of these things. You're always raising money and you're always coming up with scale, and both of these things have to be happening simultaneously. And so the short answer is we're always doing both, right? Because one enables another. Money is a really important part of what it takes to scale these processes. We've been incredibly fortunate to be backed by incredible people that have helped us do what we've done so far. And I anticipate we will continue to be backed by incredible people that will help us scale what we've done so far.
So yeah, when you were going to engineering school, did you kind of think that you would be in the money management or money raising business, or were you prepared for this at all?
Matt, I think it's one of these things that when we're preparing and training for a career to come, I think we're just focused on preparing and training well. I think what your career offers as it unfolds is what you learn and what you challenge yourself with as you go down that path.
Right. You learn new disciplines, new techniques, new processes.
That's exactly right. That's exactly right.
So how are you enjoying that part of your new life?
Yeah, I love it. You've got different kinds of challenges, but different kinds of challenges yield different kinds of rewards. And so what you really look at is the reward that it yields, not the challenge that you face. But at the same time, every challenge is a learning opportunity. And given the fact that I work at clearly an institution of learning, all sorts of learning are clearly very valuable.
Mm-hmm. So in terms of the learning front and your duties as a professor, how are you kind of rolling this out to the new generation, and how are they adapting, and how are they helping, and do you see they're taking your work to the next level?
I think one of the things that we're really going to need as we think about mitigating climate change is really talent. And we're going to need a new kind of talent that we do not have and has not been trained historically. And so this is, in fact, an incredible opportunity for universities and like people such as myself, where you have the ability to mentor and train and teach folks that are going to be instrumental to all of the change that we deliver. And I think this is also really, I think, in many ways simplified because the younger generation, so to speak, is incredibly invested in the idea of doing good and affecting climate change's trajectory meaningfully. And I think what you get with a combination of really smart people that are invested, aware, and want to make a difference, and the ability to be able to impart new information to them that's going to help build a meaningful career, I think that's what you need for the makings of success.
Well, that is really exciting. I feel like that one of the things that I've learned over the last few years of talking to so many different people is how many great minds are working on these problems, and how how exciting the work is that they're doing. And I feel like eventually we're going to get there. It's just a kind of a question of how fast. And that's why I'm really thinking with you, like, we need to get you guys the money and the resources to move that project faster. And I don't want to see you diddling around. You need to be going full blast. No breaks. I see you're, a supporter of Chelsea, but I'm not sure you're allowed to watch their games until you get hydrogen down to $1 a kilo.
That's 100% right, Matt. And that's why, alongside getting hydrogen to $1 a kilogram, the other thing that I'm really focused on is trying to make a 36-hour day, because I need a few more hours. And both of these things need to happen all at once.
Right. These are the challenges of a scientist trying to save the world. There's that balance, and trying to get that balance right. So what do you do in your life to kind of create that balance?
It's actually interesting. So I've got a young daughter, and that's always exciting, because, I think it not only does it give you purpose, but it keeps you grounded. I think that there are 2-3 things which I personally find really entertaining. I grew up by the coast in India. Going to the beach is something that I incredibly enjoy. And I've always enjoyed. And I think that's something that's both deeply meaningful to me, but it's got lots of sort of, I would say, memories of me as a child that are associated with it as well. I love to read. And in fact, I read every single night before I go to bed. And I think this is something which, again, I like really very much. And, it helps me decompress. And I like to travel. I like to see the world. And there's so much around us that we've built, we've formed, we've gone with. And being able to see what all of that is really wonderful as well.
Well, it's great to see that you're having a balanced life, because I do think that that's important, in terms of that it is a bit of a marathon and not a sprint. And we've got to stay kind of in good shape in order to keep doing this day in and day out. So good for you. We'll be right back. You're listening to A Climate Change. I've got Professor Sant on the program. He is with the Samuele School of Engineering at UCLA, and he's the holder of the Pritzker Chair in Sustainability. Tell us a little bit more about the school there, and what kind of ecosystem that is being created at UCLA that supports the work that you're doing and the work of other scientists, and generating great ideas, great scientists, and planet-saving solutions.
Yeah, thanks for the opportunity to speak about this, Matt. So, I think we've been really fortunate to have incredible leadership. And our leadership has allowed us to go out and create this Institute for Carbon Management. And like I said, we're a translational institute. And what that means is we don't do any discovery research, but we really focus on developing technologies, de-risking them, and then seeking to commercialize them. An important thing that we've I think, learned now and been able to translate and transition from an art into a science is really this process around translation. And we spend a lot of time sort of thinking about what this means. And, we start with the idea of what's known as a landscape analysis, where we try and identify a space that we're interested in and study it in terms of its shape, in terms of its organization, in terms of its structure, as a market, as a technology base, but also in terms of what the deficiencies there might be. We work with some incredibly talented people when we do this landscape analysis, and if we see something there that's of interest, we transition it into doing some verification and validation around some key technological concepts at the bench scale. If there's something interesting there that comes out of it, and we're able to go through our verification and validation in a robust manner, we will go into looking at doing effectively translation, which is going from the bench scale to building a device, prototype, or a system that's meaningfully large, that processes tens of thousands of pounds, as an example, of material per day, whether it's carbon dioxide or whether it's something else, with the idea being that you want to go from the bench scale to something which is a meaningfully large system, where you can evaluate what is known as techno-economics, you can evaluate manufacturability and scalability, and you can evaluate what is known as unit cost of production to a high level of certainty. As you go through this translation process, or the translation funnel, as we call it, we upscale and up engineer, we value engineer, and then really go out and build systems and devices. What this gives us the ability to do is it gives us the ability to learn from what we've done, and try and understand, really what are the challenges of coming up a scale curve. But it's also instilled in us an incredible capacity to be able to run these crash development programs where you go from something that's in a beaker, and 12 months later, it's sitting on a 100-foot barge in the port of LA. I think this entire process of translation and upscaling that we've been working on for about 7 or 8 years now, is I think really the most important thing that we do. It's the most important because it allows us to really determine, is a technology that's interesting in a laboratory actually worthy and worthwhile in the real world? I think this is a really important part of, how we should be thinking about what does it take to evaluate technologies that may be appropriate to mitigate climate change. I think alongside this, we've been really fortunate to have an incredible set of supporters and backers all across the world that have really bought into the mission and the work that we do. And I think being able to create de-risking platforms of this sort, not only at UCLA, but really around the world, is something that's fundamentally important to developing technologies worldwide that are all going to be needed to mitigate climate change.
It's an interesting question as to how we evaluate the kind of winners and losers in this front, and whether or not the market is efficient enough to do that, or if some kind of environmental czar would be better suited to make some of these decisions, because the market may blow it and put money into a company or a technology that's not as good. What are your thoughts on that front? Should we just let the market make these decisions, or is there some kind of central command that might, of scientific experts that might make better calls?
I think I'm not sure there's a perfect answer to this. What I can try and offer is my own perspectives, right? So the market makes decisions based on cost. Lowest cost for a given outcome is the winner. Now, this is one framework that we can use. And there's a variety of reasons why, right? So the lower the cost at which you can do it, that probably means, as an example, empirically, it might suggest that it's the most efficient process, or the most efficient process that you can bring to scale. It might have a technical underpinning to it. It's also possible that it just turns out to be lowest cost because there is no other competition, which could be a problem. Now, on the other hand, you can take a technical view to it. The issue with the technical view is that eventually, if it's not affordable, it won't adopt and scale. And so really what you need a combination between technical measures and market efficiency, which is a combination of how big could this be and how cheap could it get? You've got to really think about this in both ways. And finally, the other measure that we've got to think about, which we often don't, is how quickly could we do this? Because time is of the essence. We've got about 30 years to go to net zero and then start removing between 10 to 20 gigatons of carbon dioxide from the atmosphere, which means time is really an important basis. And thinking about how much we can do, how quickly, and then at what cost, all need to be decision variables that we have in mind. I think as we are today, often we don't consider this three-pronged decision basis. We typically just focus on sort of lowest cost, but maybe there's a need for more than just lowest cost as we think about these decisions, particularly how fast and how big.
In terms of, you're talking about some interdisciplinary type approaches to this. How involved have you gotten in, say, public policy, given the fact that a lot of this has to do with public policy and tax? How are we taxing certain items, whether it's carbon or other pollutants, or giving credits to people that are taking stuff out of the atmosphere? Are you engaged in that on that front at all?
Yeah, we provide advice and input to policymakers all around the world. This is an important aspect of what we do. But fundamentally, I will say that while we do provide advice and input, more than anything else, we really see ourselves as technology innovators. And really, we see technology as the lever by which you essentially drive solutions to arrive at the lowest cost. In effect, I think this is an important basis because, while policy is indeed important, we need to be doing our part of also trying to figure out what's the lowest cost pathway of being able to make a difference or to deliver a given outcome. And you need both to go hand in hand. You don't want policy to race ahead of technology, and you don't want technology to be too early and far ahead of policy, because then technology might fail independent of how good it is. And so really the key here is to be able to inform policymakers and continue the development of technology so that they sync, so to speak, in lockstep on a time scale with each other, but don't hold each other back.
And that is a balancing act for sure, given our current public policy environment in the U.S. But maybe we'll switch gears a little bit to this entity, CarbonBuilt reverses technology. How does it work? And how did you create a new kind of cement?
Yeah, so this is something I'm really excited to speak of. So CarbonBuilt was spun out on the basis of technology for which we won a Carbon X Prize, the NRG COSIA Carbon X Prize. We're the only university in the world to have ever won a Carbon X Prize, and I'm really proud of the fact that we built a team that went out and did this. The general idea around the CarbonBuilt technology is actually really straightforward, and what we're trying to do is we're trying to convert carbon dioxide into concrete. And so, in essence, we are using a series of really simple chemical reactions that happen at ambient pressure and ambient temperature that allow us to produce concrete products. All of this happens within, it's like I say, you can think about this as a convection oven and some Toll House cookies. Instead of having a regular convection oven and regular Toll House cookies, you've got a slightly different Toll House cookie, and you've got a convection oven that, in addition to having air, has carbon dioxide within it. And you bake these wonderful cookies that look and taste exactly like the regular cookie, except for the fact that they have a carbon footprint that's between 70 to 100% lower. The reason that we were really excited about this pathway is the ability to deliver a product at cost parity, which has functional equivalence, but a carbon footprint which is 70 to 100% lower than a traditional concrete product is pretty incredible. I mean, this is truly disruptive and truly transformative when viewed from the perspective of the construction sector, which is indeed a classic commodity business, so to speak. This is also an approach that, once again, we sort of taken through the Institute's translation funnel. And the nice thing about it is that now, in a matter of just the next couple of weeks, next couple of months, CarbonBuilt will actually be starting operations of its first commercial plants.
That is exciting. So tell us more about CarbonBuilt, and are there investment opportunities there, or is that something that's privately held? What's going on that front?
So CarbonBuilt is a venture finance company. Their CEO, Rahul Shendure, is an absolute superstar. And, I think they've been doing some incredible things. They built an incredible team. They're based out of Los Angeles. I think they're going to be really focused on building as many plants as they can all around the world. And so, indeed, I'm sure there's ways that people could be working with them.
Well, it's exciting stuff that you're talking about. You're listening to A Climate Change. I've got Professor Sant on the program from UCLA, Institute for Carbon Management. Right before the break, we were talking about concrete and cement, and I think I misspoke, and the professor has corrected me. Thank goodness we have him. I think I said cement, and it was concrete. I think that was the correct answer. But that's why we have the professor on the program to fact check me and get me on the right path here. One of the things which you had mentioned earlier is the green premium, and that's talked about both in Bill Gates's book about, where he was talking about that we have these green premiums that we're going to have to deal with. And his book was How to Avoid a Climate Disaster. And then also, I hate to mention it, but you kind of already alluded to Speed and Scale, which John Doerr had written his book about a global action plan for solving our climate crisis. And he created an institute up in Stanford regarding sustainability. I was going to say competitor, but more like a colleague in the process. Those are a couple things that I wanted to ask you about. Tell us more about your view about the green premium, and how much do we have to sustain a product or solution before we should expect that that's eliminated?
When we think about the green premium, this is actually, I think, at least in my view, really problematic, because in effect, what we're saying is we are going to increase our cost of living to make a difference. In a developed economy, this might be potentially tolerable. In a developing economy, for example, really, which is represented by the global South at large, it's intolerable. And so the idea that we are going to mitigate climate change by impoverishing the world simply does not sit well. I think this is really where technology plays an important role, and why technological innovation is so important. Because technological innovation is really the lever by which you compress and eliminate the green premium. What this requires, however, is that we have the ability to scale and stage, that we come up and scale and we stage how we come up and scale in a manner that we compress and eliminate the green premium as quickly as possible, if it does exist to begin with. But I think a fundamental challenge that we should be laying out for innovators all around the world is, how would you eliminate the green premium? And so really asking the question around, what does innovation need to involve for the green premium to be eliminated at the beginning is maybe a really good challenge question to be able to set. I think with lots of the work that we have done and we continue to do, we really sort of push this thinking onto ourselves because we think that this is really what is needed to create a market pull that is organic, where you don't rely on policy, but you really rely on the idea that reductions in emissions and embodied carbon intensity can be delivered without changing the cost and price, particularly the price of materials and products and services. I think if we are able to embed this general thinking into society at large, that we can reduce carbon footprint, it can happen at the same price, and it can happen quickly so long as we stage it and manage it, I think that would be a wonderful direction to go. The next part, which turns out to be really important, is related to this.
I get that, and that's kind of I think the goal, and in some respects the miracle. But I think another part of that is the equation of not pricing into the model the cost of the damage to the environment. And for so long, basically, industry has sold us the good or whatever, that destroying our air quality or our water quality is not a cost to us. And it's just not embedded in the way that we price out our products. And to me, that was, maybe that worked 200 years ago because there wasn't an immediate cost to it, but now there's a cost to it and we're not accounting for it. It's poor accounting to not say, hey, you're making the air in Los Angeles unbreathable. That's a cost, right?
That's 100% right, Matt, right? So if you think about criteria pollutants, for example, we think about smog in Los Angeles. There's a reason why smog is gone, right? We technologically innovated a pathway to be able to get rid of it. But most importantly, we set in place really strong policy and laws, for example, under the Clean Air Act, that allowed us to be able to deal with criteria pollution. Now, but what that requires is really allocating a precise, I would say, metric that implicates the damage caused by a criteria pollutant to the environment and human life. If we could align on a social cost of carbon and really understand what that social cost of carbon is, that gives you sort of an accounting mechanism, just like you suggested, of being able to understand what the damage to the environment and damage to human beings in general really turns out to be. If you factor that into the cost basis, of course, this gets a whole lot easier. But as you do know, this is a difficult consensus to arrive at. And in a time in which consensus might be hard to arrive at, I sort of have to step back and say, count on technology to push forward as aggressively as possible, because that continues to be the only really strong lever that you have.
Right. I hear what you're saying. As a true realist, you better be able to beat people on price, and then you win the argument hands down. Obviously, our concrete is cheaper than yours, therefore you should use it. And then it doesn't matter whether or not it's green or blue or purple, you just want to use it. Now, in terms of speed and scale, that is a definite challenge. How are we going to do that? What are we going to do? What do we need to do more of in order to pick up the speed and the scale of what, brilliant ideas are being implemented around the world? That's happening. How do we move them faster and at greater scale?
Yeah, I think so. I think there's a couple of things to be thinking about here. So I think there's a huge diversity of ideas that people are proposing, suggesting, offering, validating, verifying, all of the above. And I think at some point we'll have to sort of start this thing to ourselves and say, here's a couple of, I would say, buckets of ideas that we really need to push forward really quickly. So while we can continue to, innovate new buckets, add to the existing buckets, we're going to have to make some bets because there's some things that we'll have to bring to scale quickly enough. And so I think some of this really involves sort of thinking about what are the things that we could do at the biggest possible scale, quickest, and at the lowest cost, and sort of developing a decision-making framework, a decision support framework that allows us to take large and meaningful shots on goal without just taking shots on goal. So it's not simply about number, but it's really about quality and the value of the shots that we take. I think this is one part of it. The second part of it that we really need to think about is sort of
can I stop you right
Yeah.
there? Because that's such an important piece. I want to ask you a follow-up on that is how do we get to that point? It's kind of similar to my question earlier. Do we have this czar of, the environment who says these 10 shots on goal are the best shots on goal, or do we let the market decide that?
Matt, I think you need a combination of both. And I don't have a response for us as a society at large. But what I can say, what we've been doing at the Institute of Carbon Management is really looking at technologies and the development of technologies that allow us to abate the largest quantity of carbon dioxide emissions at the lowest cost, and considering industries that are most foundational to our way of life. It's between these three sort of support bases or decision bases that we've been thinking about all of the work that we do, because we think this is a lens that matters. Because you don't want to change people's lives. You want them to continue to have improvements in life, but you want to reduce carbon impact of each one of us living our lives in a particular way. This is the framework that we've applied to ourselves. And it allows us to guide how the support that is provided to us is best deployed. There's probably some analogy of this that we should be thinking about more broadly as well. And whether it happens through one czar or for every nation or one czar at a state level, is maybe a question to be asked. But at the same time, we've also got to keep in mind that there is a need for speed of decision making. And so we need to arrive at this framework, whatever it turns out to be, meaningfully fast. The challenge with the market just on its own is that markets take a long time to stabilize and pick a winner, or often they end up picking a winner because there isn't clear competition that has emerged. And so I think, we need a balance between sort of short-term view and a longer-term view. And like I said, thinking about how quickly, how much, and at what cost, and using that to really guide which of these buckets we promote and which of the bits in the bucket we promote and which ones we say, we'll punt for another day.
Well, it's been a pleasure having you on the program, Professor Gaurav Sant of UCLA, Samwali School of Engineering. Amazing work that you're doing out there. And, I feel like you're on the cutting edge and we should all kind of support that great work. Everybody go out, check out the Institute for Carbon Management website, icm.ucla.edu. And follow the work that's being done and actually, see what you can do to support the types of things that the professor's talking about. And because we can do this as a group. And if we all are aligning behind great people, we have greater power. So I encourage everybody to get involved and support the great work that's being done over there at UCLA. And thank you so much, Professor, for leading the charge there.
Thanks very much, Matt. Thanks for having me.
Yeah. And, one of the things that I have incorporated into my life is a yoga philosophy. And one of the poses that I like to do is a kind of a gratitude pose. And I'm grateful for having you on the show, grateful for the work that you're doing, and wish you all the best going forward.
Thank you, Matt. You're far too kind.
Check out our website at aclimatechange.com. Everybody tune in next week.